In this video, we're going to explore percents in more depth, looking at part-whole relationships and increases of percentages, as well as comparing one part to another part. In this first problem, you're given three very similar problems. They'll all have different answers. 40% of 200 equals 40% of what number equals 200, and 40 out of 200 is what percent. When you take a look at this first problem, 40% of 200, 200 is our whole quantity. The whole, we're now trying to find a part, 40%, or 40 per 100 of 200. So let's start with our known quantity here. We know, in this case, 100% of our number would be 200 because 200 is our whole. So when we want to find 40% now, we can go straight from 100 to 40 if we want. I think probably by dividing by 2.5, or we can kind of take a simpler route and just go to 10% would be 20. And then 40% would be 4 times that, so 80. An alternative way to start thinking about these types of problems, which may not be as useful for this, is thinking what percent means. So if you see 40%, that is 40 per 100. So it's a relationship of 40 per every 100. So if our whole value, so if this is percent, is like a part-whole relationship of 40 per a total of 100. So if our whole is 200, all we need to do is just multiply by 2. And it would be 80 would be our part of 200. That's another way to look at these problems. I'm going to focus more on this strategy, but it goes back to versatility and having multiple pathways to try a problem, which is why I introduced that. In the second problem, 40% of what number equals 200? So in this case, we're missing our whole. But we know what the part relationship is. We know that the part of 40, or 40%, corresponds to a value of 200. Now we need to work in a different sort of order to find out what is our whole thing. What is the whole, or 100%? So to go from 40 to 100, we are multiplying by 2.5. And whatever we do to one side, we must do to the rest. So we're going to multiply by 2.5 here. And that is going to be 500. So we could say 40% of 500 is equal to 200. And you could think how you could have done this using the other strategy as well. In this case here, we're just given two parts, or a part out of a whole. So now we know the part is 40. Now this is a part-whole relationship, and it's out of 200. Well, remember, percents are out of 100. So 40 out of 200 equals, now we have to just divide by 2, is 20 out of 100, or 20%. If you're doing this sort of problem in a table, you can kind of set it up as just a part or a whole. And the part is 40, the whole is 200. And to be a percent, we need this whole to be 100. And so that's how we get from 20 out of 100, or 20%. So you'll see these types of problems quite frequently. On the next, this is a shopping problem. I'm going to move through this rather quickly. Ronald is shopping for a new outfit. Calculate all of the missing values in the table below, rounding to the nearest penny. And then calculate the total amount of money Ronald will spend on his new outfit. So if he's buying a shirt that originally cost $35, and he's getting a 25% discount, I'm just going to do a quick table over here. 100% discount, if he was getting it for free, would be $35. He's getting a 25% discount. So let's divide 35 by 4, because we need to divide 100 by 4. 35 divided by 4 is equal to $8.75. Now remember, that's the discount. So in order to find out how much he's paying, we need to use subtraction. Alternatively, if he gets a 25% discount, we could think that he's paying for 75%. So we could find the price that he's paying by going from 100 to 75 or multiplying this by 3. I'm just going to use subtraction. $35 minus $8.75, and that will give us a value of $26.25. So it will cost him $26 for his shirt. His pants are 40% discount, and we know that 40% corresponds to $12. So we know a 40% discount is $12. So how much were the pants? We have to figure out 100%. Remember, that's times 2.5. So we need to do 12 times 2.5. It's to get from 40 to 100, it's times 2.5. So we have to do that same thing here. 100% must correspond to $30. I'm sorry, the amount of discount here is $8.75. So he's paying $26.25. I didn't notice this just said discount though, not sale price. The shoes are 15% discount. Well, this is pretty simple. 100% discount is $75. 10% discount is $7.50. And to get to 15%, I'm going to add 10% and 5%. So 7.5 divided by 2 is $3.75. So 15% is going to be 10% plus 5%, or $7.50 plus $3.75, and that's $11.25. So in this problem, he has a discount of $11.25. So the end question was, what is the total cost? So to find the total cost, we need to find how much he's spending. Here, $35 minus $8.75 discount gave us $26.25. Here it was $30 minus a 12% discount, minus a $12 discount was $18. And here was $75 minus $11.25 discount. So he was paying $63.75 $63.75. So to find the total cost, let's add all those up. $26.25 plus $18 plus $63.75, and that gives us $108. Ronald's outfit will cost a total of $108. Okay, we're going to do a couple problems of looking at analyzing data with percent increase and comparing parts to each other. The number of students in the chess club was 14 in 2014, I'm sorry. In 2015, the number of students increased to 42. I'm going to represent that information in a T-chart of 2014, 2015. We went from 14 students up to 42. What was this percentage increase? Well, to think about percentage increase, we need to think about, to go from 14 to 42, what percent did he need to increase by? I know that to have a 100% increase, we would have to increase by 14, or double the number of students. We increased by, I'm going to look at the number we increased by. We went from 14 to 42. That is an increase of 28 students. So we increased by 28 to go from 14 would be 100% to 28. Let's double it. So we had an increase of 200%. And that increase of 200% corresponds to an increase of 28 students. Let me just clear. And now I'm going to just get rid of this question and pull up a new one now. The number of participants in 2015 is what percent the number of 2014? So if we go back to that 2014-2015 ratio table, we went from 14 to 42. So we want to say the number of participants in 2015, which is 42, is what percent the number of 2014? I'm going to do the same type of table again. 100%. So we want to find out 2015 is what percent of 2014, or 14. 42 is what percent of 14. Well, 100% of 14 would be 14. But now, instead of looking at that increase, we want to get to 42. So to go from 14 to 42, it's like multiplying by 3. And we'll do the same thing here. So it's 300%. Wasn't that interesting? If we compare that last problem, we said it was an increase of 200%. Well, if we start at 100% and we increase by 200%, we get to 300%. And if you did this problem the first time, you could have seen, okay, we went from 100% to 300%. That's an increase of 200%. Or 42 is 300% of 14. And then for this last problem, same type of deal. But now it's reversed. The number of participants in 2014 was what percent of the number of participants in 2015? So now you're saying 14 is what percent of 42? Let's set it up. Well, 100% of 42 would be 42. But we're going to 14. So now we're just working in reverse. We're dividing by 3. And we have to do the same thing here. So 100 divided by 3 is 33.3. So the number of students in 2014 was 33.3% the number of students, as many students as 2015. So those are the concepts for today. You may need to rewatch this to practice some of these ideas.